The next topic of our syllabus is atoms, elements, and compound. And the first subtopic in this category is differences between elements, compounds, and mixture. Element is a pure substance made of one atom, one type of atom only. Okay, and compound, it is a pure substance formed when two or more elements chemically combine in fixed ratios, like water, carbon dioxide, and there are many other examples as well. Mixtures are comprised of two or more substances typically combined, can be separated by physical method. Okay. Um, Examples of mixture is air, sea, water, and there are other examples as well. Then next thing is describe the structure of atom as a central nucleus containing neutron, proton, surrounded by electrons in the shell. Okay. So this is about describing the atomic structure. An atom has a central nucleus, and around that nucleus, we have electron-filled shell. So electrons, they are assumed to be moving around in these electron-filled shell. On first shell, we have two electrons. In second shell, we have maximum of 8 electrons, and so on and so forth. So, um, and in the center, in the nucleus, we have protons and neutrons. Okay, protons and neutrons, they are present in nucleus, and electrons are revolving around the nucleus in the electron-filled shells. So this is the atomic structure for you guys. Next thing is state the relative charges and relative masses of a proton, a neutron, and an electron. So proton, it has a positive charge plus one charge. Electron, it has minus one charge, and neutron is not having any charge. So proton, the relative mass of proton and neutron is 1, and for electron it is 1 upon 1836. That means it is negligible. The proton number as represented in periodic table is number of proton in the nucleus of an atom. Number of electron in a neutral atom is equal to number of proton or atomic number. Next thing is the mass number or nucleon number is the total number of proton and neutron in the nucleus of an atom. Determine the electronic configuration of an element and their ions with proton number 1 to 20. Okay. So electronic configuration, if it comes in your exam, it will be from uh, hydrogen, okay, and going on to an element having a mass number of 20, or proton number of 20. So the first 20 elements will be included when they ask you to draw the atomic configuration or electronic configuration of an atom. Okay. So first 20 elements will come only. The electron filled shells are in order of 2, 8. In first shell, there are maximum number of 2 electrons. In second shell, there are maximum number of 8 electrons. In third shell, there are maximum number of 8 electrons. Again, okay. And the rest of electrons will come in the last shell. So here is the product table with you guys. So you can see over here that atomic number 1, the first element of the periodic table is hydrogen. So first the periodic table is hydrogen, and then we have helium, and so on and so forth. Lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon, sodium and magnesium, and then aluminum, and then silicon, phosphorus, sulfur, chlorine. So the electronic configuration of these elements are included in your syllabus up till calcium. Okay. So we have 20 elements, first 20 elements. So the electronic configuration which can come in your exam is for the first 20 elements. Okay, then the next topic is define the empirical formula of a compound and the simplest whole number ratio of different atoms or ions in a compound. So empirical formula, sometimes it is mentioned as a part of stoichiometry in the chapter of stoichiometry, but actually it is part of atoms, elements, and compound. So empirical formula for covalent compounds, we have uh, such compounds which have two formulas. One is empirical, that is having the simplest ratio of the simplest ratio of elements combined in the chemical, and then we have molecular formula. Okay, an example is given over here to you guys. It is ethane C2H6, and for that the empirical formula will be CH3. Okay, empirical formula is not the molecular formula. It is showing the ratio in which elements are combined together. Okay, in case of covalent molecules, you need to deduce the formula of a simple compound uh, from the relative number of atoms or ions present in a model or a diagrammatic representation. So you have to count each type of atom. A diagrammatic representation means it can be giant molecular structure given to you guys, and you have to judge what is it, what type of compound is it. And how you can do it is count each type of atoms shown in the model and write down their ratios as subscript. Okay. For example, two hydrogen atom and one oxygen atoms, if they are shown in a molecular diagram or molecular structure, then it is H2O, water. If it is sodium chloride, then giant lattice is shown in the diagram, and you have to judge that what is the formula of the compound. Okay. So next thing is deduce the formula of an ionic compound from charges on the ions. Okay. So ionic compound, you can just remember this rule that combine ions. So total positive charge is equal to total negative charge. In an ionic compound, the number of ions, number of positive ions, and number of negative ions are in such a ratio that the positive charge is equal to negative charge. For example, in magnesium chloride, magnesium is in group 2, it has the charge of +2, and chlorine, it has charge of minus. So, in order to balance the charge, positive charge is equal to negative charge, two chlorine ions must participate. Okay. And there is another example of sodium sulfate. In which sulfate ion, it has charge of -2. So two sodium ions, each having a charge of plus, will be used in order to balance the number of the negative charge, total negative charge. Now, next thing is, so, and this is really important in order to reduce the formula, molecular formula of any compound. Okay, ionic compound. This part is really important. Okay, and it is a key point, really important. You need to understand this. Otherwise, you will not be able to deduce the formula of any unseen chemical compound. कोई भी unseen chemical compound आ सकता है आपके पास सिलेबस के अंदर, तो आपको ये उसको उसका फॉर्मूला लिखना आना चाहिए। कोई भी आयनिक कंपाउंड आपको कोई भी जो आपके पास मेंशन ना हो, कभी आपने उसका नाम भी ना सुना, एंड इट इज एन आयनिक कंपाउंड, यू नो दैट मीन्स के मेटल और नॉन मेटल उसमें रिएक्ट कर मतलब हो इन्वॉल्व। सो आप समझ जाएंगे कि दिस इज एन आयनिक कंपाउंड, एंड you will use this same technique to find the chemical formula of it. Next is state that in periodic table, group 8 noble gases have a full outer shell. Okay. Noble gases, they are having full outer shell. We can look at the periodic table over here. So this is group 8 in front of you guys. As you can see, helium, it has proton number of 2, means it will be having only one electron filled shell having complete two electrons. In case of neon, it is 10. So in first electron filled shell, it will be having two electrons, and then the next cell it will be having eight electrons. Similar is the case of argon. In this, we have the electronic configuration of 2, 8, and 8. Okay. And after that, it is not part of your syllabus, and you guys cannot use the 288 configuration to find the electronic configuration of krypton, xenon. So don't worry about it. Okay, you will study about it in E levels, advanced levels. Okay. Next is number of outer shell electrons, valence electrons is equal to the group number in group 1 to 7. Okay. So whatever is the group number, the valence electrons are same. Means K for hydrogen it is +1 because it is not part of any group. Some periodic table it is part of a group 1, but it has some different properties from alkali metals, so it is a bit different. Okay. Then we have lithium, sodium, potassium, rubidium. All of these elements they have one valence electron in their last electron field shell, the outermost electron field shell. And in group 2 there are two electron in outermost electron field shell, and it is known as valence electron field shell. Valence electrons. Okay. Now, next thing is number of occupied electron shells is equal to uh, the period number. Okay. So this is the group number. The all the columns they are the group number. Period numbers are not mentioned in the periodic table, but we consider the first row as first period, and then period number 2, 3, 4, 5, and so on. Okay. And period number represents the number of electron filled shell. For hydrogen and helium, it is only one. Lithium till neon, it is two. And for sodium till argon, it is uh, three. And for calcium and potassium, it is four. Four electron filled shell will be there. The next thing is define isotope. What is isotope? Isotope are atoms of the same element having same number of proton but different number of neutrons. Proton is the identity of an element. Okay, if you change the proton number, the element will be changed. So obviously, since isotopes are atoms of same element, so proton number cannot be changed, but number of neutrons will be different, and obviously mass number will also be different. Chemical properties of an isotope. Isotopes have same chemical properties because they have same number of electrons and same number of electronic configuration. So the properties, chemical properties of isotope will be same. Then we have interpret the and use symbol of for atoms and ions. Okay, you must know how to use the symbols. That means for carbon it is C12 6 means 12 is the mass number and 6 is the number of proton. So 6 proton and 6 neutrons are there. Okay, so you need to calculate the number of proton and neutron using this data. Okay, and for chloride ion. Ion means if there is a negative charge means total number of proton is equal to total number of electron in a neutral atom. And in ion, if there is a negative charge means there is an extra electron in this ion. Okay. So originally there are 17 electron, and then there is a minus sign means the number of electron will be 17 plus 1, 18 electrons. Proton will be 17 and neutron will be 35 minus 17. Calculate relative atomic mass. How to calculate relative atomic mass? Okay, you guys must have studied about mass spectrometer, a device which is used. Okay, the mechanism of that device is not part of our syllabus, but it is the device used to measure the relative abundances of different isotopes in a sample of an element. Okay. For example, if you take a sample of chlorine, okay, there is a graph on y-axis. It is having percentage abundance or abundance of. If it is in percentage, then you have to divide it by 100. If it is um, in ratios, then you have to sum up the ratios and then divide. So there are two peaks. Let me change the color. There are two peaks. One will be of 35. The other one will be of 37. Okay, 35 and then 37. So you need to calculate the relative atomic mass. So since there are only two isotopes, whatever abundance is written over here, you will just multiply it with the mass number, which is 35, and then you will read the relative abundance of isotope chlorine 37 isotope, and then you will multiply the abundance with mass. Obviously, if it is in percentage, the sum of all percentage must be equal to 100, then you will divide it by 100. If it is not in percentage, it is in ratio, so you will add all the ratios and write it over here. Okay. Sometimes the ratio की form में mention होता है, so you have to take care about it. Okay. Next is formation of ions in ionic bonding. So in ionic bonding, there are positive ion and negative ion. Positive ions are also known as cations. Negative ions are also known as anions. And positive ions are formed when atoms lose the electron, as ionic bonding is transfer of electrons. So when atoms lose electron, they form positive ion or cations, and when they gain electron, they form negative ions. Then we have giant ionic lattice structure. What does that mean? Ionic compound have a regular three-dimensional structure, 3D arrangement of alternative positive and negative ions held by a strong electrostatic force. Okay. Sometimes when you mention why ionic compounds have high melting point, so most of the students write that they have a strong intermolecular force. No, intermolecular force are for molecules which are made up of covalent bonding, which are formed by covalent bonding. For ionic bonding, you use the word electronic configuration. Okay, this is important thing to remember. Then we have definition of ionic bonding. Obviously, we have already discussed about it. That ionic bonding is a strong electrostatic force of attraction between positively charged ions. Formation of ionic bonds, dot and cross diagram. Okay, you guys have already studied about it. Form when metal atoms lose electron and non-metal atoms or polyatomic ions gain electron to achieve noble gas configuration. Example is of sodium chloride. We have drawn the structure in class as well multiple times. So you guys are well familiar of how to draw the dot and cross diagram of ionic compounds. Next is properties of ionic compounds. Ionic compounds are having high melting and boiling point, strong ionic bonds require much energy to break because they have strong electrostatic force of attraction between ions. Conductivity. Ionic compounds, they conduct electricity when they are molten or in aqueous condition. The ions free to move, but not when they are solid because ions are fixed in lattice. Okay, they cannot move since electricity is the flow of charge. So when the ions they are not able to move, they will not be able to carry the charge. Okay. Next, covalent bond. How you define covalent bond is it forms when two atoms share a pair of electrons to achieve a noble gas configuration. Um, Examples for the formation of covalent bond: hydrogen gas, chlorine gas, water. Two bonds, two OH bonds are there in water. In methane, there are four carbon hydrogen bond. In ammonia, there are three nitrogen and hydrogen bond. In chlorine, there is one hydrogen and chlorine covalent bond. By the way, hydrogen chloride. This is hydrogen chloride, not hydrochloric acid right now. Okay. Hydrogen chloride is a covalent compound, but when it is dissolved in is um, not an ionic compound, but in hydrogen and chloride ion. Okay. When it is dissolved in water, converts itself into hydrochloric acid. Okay. So become HCl aqueous. And in that condition, hydrogen ions are dissociated and chloride ions are also dissociated in an ionic form. Next thing is property of simple molecular compounds. They have low melting and boiling point, weaker intermolecular forces between molecules, poor electrical conductivity, no free electrons are there or no free ions are there. So there is no support to carry charge from one place to another. Giant covalent structure. In giant covalent structure, we have examples of diamond, graphite, and silicon dioxide. All have atoms joined by strong covalent bonds in giant lattice. Okay. You guys can see the structure online or in books as well for diamond and graphite and silicon dioxide. Graphite and diamond, they uses of related structure. They are graphite and diamond. They are made up of pure carbon. Okay, in graphite, layers of carbon atoms with delocalized electron um, is present. See, these delocalized electrons, they conduct electricity and they help the layers to slide over each other. So graphite is used as a lubricant because it is soft and it conducts electricity. So it is used as electrode in electrolysis. Diamond, on the other hand, has each carbon bonded with four others. Okay. In graphite, each carbon is bonded with three other carbons. Okay. But in diamond, each carbon is bonded with four other carbons. And it is very hard and use as in cutting tools. Okay, where strong cutting tool is required, diamond is used to cut usually stones. Okay, in marble cutting and stuff like that. Similarly, between diamond and silicon dioxide, there similarity between diamond and silicon dioxide. Both have a strong covalent bond throughout a giant lattice, having high melting and boiling point. High melting point, boiling point की दूर की बात है, melting point ही उनका बहुत ज़्यादा होता है. And they are hard. They both are hard. Okay, diamond is hard, so is silicon dioxide. Okay. Next thing is metallic bonding. What is metallic bonding? It is the electrostatic force of attraction between positive metal ions and a sea of delocalized electrons in giant lattice. Metal atoms, they are really close to each other, and since they are really close to each other, the outermost electrons, they find no room to evolve revolve around a single atom, so they get delocalized, and there is a sea of delocalized electrons around the positive ionic lattice. Okay, so this is how a strong electrostatic force of attraction between electrons and positive ionic lattice form, and this is known as uh, metallic bonding. Next thing is the properties of metal. Metals, they are good conductor of heat and electricity because of the freely moving sea of electrons. Okay, so they are good conductor. They carry charge. They carry heat from one place to another. Metals, they are malleable and ductile. Layers of ions can slide over each other without breaking metallic bond. Okay.